All right. Hi, guys, and welcome to this webinar. The topic for today is synthetic data. And my name is Fredrik Rönnlund. Together with me, I have
Ruksi Laine. Hi.
And yes, so the topic is synthetic data. We have a couple of slides, we have a demo, and we have your questions that we hopefully answer. Why did we choose this topic? Why should you have synthetic data?
Yeah, so for synthetic data to be useful, you don't need, there's the situation that you don't have abundance of data. So if you are scarce on data, that's a really good point to at least start thinking about synthetic data.
Yeah. So, I mean, we all know that there's an abundance of frameworks, there's abundance of different tools and algorithms from LSTM to CNNs and so forth. But,
yeah, definitely.
But today we are going to touch upon data.
Yeah, like just if you don't have enough data, like in general, but even if you are like missing some specific cases, let's say some outliers, then the data synthesization is important.
Yeah.
So other options, if you are scarce on data, is to use some open data.
Yeah.
So for example, like awesome public data sets. GitHub repo has plenty of interesting data sets like agriculture or building or
medical and governments have put up data there and stuff like that. So
yeah, definitely. And like also the Kaggle community organization, how do you want to call it? There's plenty of good data sets over there. So I would definitely recommend also checking that out.
Yes.
And let's get to the agenda of the day. So first we want to talk about what is synthetic data, then why should you use synthetic data. We covered it a little bit already, but we'll go like into more deep into the pros and cons of that. And then finally covering how to use synthetic data. Of course, like synthetic data is like it's like how would you say it? It's a use case specific, let's just say that. So it's always depends on what you're doing.
Yeah.
And then we'll go to demo. And lastly, we have some questions and Q&A, like we are answering those questions. We received plenty of questions before the webinar, and we'll also check if we received any more questions on the chat.
Yes. So, I mean, exactly. Put out your questions in the chat. Some of you emailed us questions, or when you signed up, we got your questions, so we can answer them after this, or if we don't have time, we'll answer them in private in email then.
Yeah.
But yes, let's go into the what is synthetic data in practice.
Yeah, let's get to the beef. So, synthetic data, it's a manufactured information rather than recorded from real world events. So simply put, let's say you're rendering 3D images from cars or like using statistical truths about your data to generate new data. It's separate from data augmentation because data augmentation is basically like
flipping the pictures or making alternations of your customers, switching people's first names to last names and stuff like that. But
so the augmentation is close to synthetic data, but it's still different kind of beast.
With augmentation, you can only get a little bit further. You can't possibly cover the edge cases. Synthetic data is really good for the kind of data that is hard to find otherwise.
Yeah, definitely. Will we be sharing the slides as well? Yes.
Yes.
Some way or form. Yes, we will. So main data types. So this is what I have been personally working with, but of course there's like almost anything goes with synthetic data. So you have some kind of 3D environment, like let's say a game engine or a game or something that renders 3D world. It maintains a 3D world. The easiest and most obvious thing that you can do is take images or video, but also from that 3D world you can generate LiDAR, radar like data or other kind of radar data.
Yeah.
And then there's audio.
Audio is a tricky part. I mean, you could do it from like text to speech, but how good quality speech do you get from it, or nature sounds or stuff like that? So
yeah, you can definitely do audio synthetic data, but it's not as straightforward as using like 3D world to render images.
Yeah.
Then there's tabular data like numerical or like just text. Text generation is hard, but the tools for that are by like the quality of the model. Yeah. Then we have the time series data. So if you have a series of numbers, you can easily generate more based on the standard deviation or distribution of the data points.
Yeah. Locus has a good point online that our own image might come over the picture every now and then, so we'll be mindful of that in the future. We'll switch between those.
I know that you don't maybe want to see us all the time, but like, I try to switch it around so you can at least have a chance to see the slides.
You can see that we are actual people and not sort of synthetic data
generated. So we are not AI.
We are not simulations yet.
Let's see. So we are on this webinar, we are mostly focusing on the 3D generation, mostly because it's just more visual, but all the same principles apply to other data types too.
Yeah. It would be hard for us to just show audio in this webinar. It would be a radio program then or something else.
Yeah, definitely. So two main categories of synthetic data. You have partial synthetic data. So this means that you have, for example, images and you embed 3D objects in them. It has its uses, but then you have less control. Then you have option to have this like fully 3D worlds and use that as the reference point. And these all both apply also to, for example, tabular data that you are just replacing some values on the full sample. It's either always partial or full.
Like you can think of like a traditional SQL database. Do you want to create everything, or do you want just to create like overwrite some parts of it? So
yeah, let's say if you have some like financial transactions, you might only want to focus on anonymizing the personal information.
Yeah, for GDPR reasons, for instance.
For instance. And the main thing that you get from having the fully synthetic data is that you have full control over the environment where the data is, like how it's presented and how the events are being shown.
Yeah, we have a pretty nice Unity example coming up after this.
Yeah. So we have a brief example at some point to show how it all comes together.
Yes.
But like just highlighting that it's not augmentation. When we are talking about data augmentation, we are most of the time speaking about like rotating the images or cropping the images, but they are both have the same kind of like outcome, that they are generating more data where your models can learn from. Let's see. So that was like in a nutshell what is synthetic data. But let's go to the next section about why should we be using it. So why they use synthetic data? The main application in a machine learning context, at least, is to generate the training dataset for supervised learning. Of course, you can use other kind of learning also, like semi-supervised learning, but usually it's for the fully supervised learning stuff. We'll be focusing mostly on the training side of it, but you can also use it for testing, for validation, and stuff like that. First good point, pro of synthetic data is that you have basically unlimited amount of training data. Like when you get it working, and like you can just push the button and you get data, but then you need maybe sometimes change the data generation so that you have new edge cases covered. Let's say like if you have modeled this 3D city where you have these cars driving around, you might want to, for example, model traffic lights. Let's say you didn't have traffic lights before.
Yeah.
It creates new variables for the system and makes you have more control over the individual events that you're recording.
And then, of course, depending on the simulation, you might be good with only having synthetic data, no real data. Or then your question might be that could you train the model with synthetic data, but only do the actual validation with real data? Then, and sort of, yeah, there's interesting questions there.
Yeah.
It depends, of course, from case to case what you're doing. I mean, if you're doing it with audio or tabular data, it's different than from image data.
Yeah, so I can say that I wouldn't go into a self-driving car that has been trained fully on synthetic data.
Yeah.
Like I wouldn't do it because like at least it needs to be validated.
Yeah, but then again, would you go and play a Microsoft Flight Simulator that's only been trained on synthetic data? Yes.
Yeah,
so
yes,
I mean, it depends on the use case. So.
Yeah, it depends largely on the use case, and of course you need to always validate with the like real life data. Yeah. I would say that. Yeah. But like. So like building the high fidelity data pipelines, it takes time basically. Like our example is rather simple. It's just a rotating car, but like it's the same principle. You will have way to control the 3D objects. It can be driving around. It's just it's simplified example.
Yeah.
We have questions. Okay, guys, in your example, rotating car with the background, this seems really more like augmentation operation rather than true synthesis. Yes, you are correct. Like I mentioned just now, is that we try to keep this example simple. We have more in-depth examples coming and some tips how to proceed with those, but like we didn't build a full simulation for this webinar. We are basically educating the use cases and the concepts of this.
Yeah.
Let's see. Next.
The principles that we're talking about are still valid or are very much valid in synthetic data generations. Like, for instance, labeling that we're going to jump into.
Yeah. Like one major benefit of using synthetic data is having really good labels. Essentially, you don't need to label anything because you place the object there, you precisely know where it is.
In the image case, we know it on a pixel case, not even a box around it. We know 100% how it's going to
So
look.
like we get perfect labels. Yeah. Like it's hard to get like that good labeling data in real world use case.
Yes.
Like basically like segmentation of the whole object.
Yeah. And I mean, we are talking about images. The exact same thing applies to audio as well. If you create synthetic audio with, let's say, text to speech and then put some background noise on top of it, you know exactly which part is background noise and which part is the speech. So you don't have to try to guess or train any models for it. When you do synthetic data, you always know what it is.
Yeah, that is exactly right. Let's get to the next. So one other use case of like advantage of synthetic data is that it can be used to simulate expensive hardware. Let's say you have some image recognition task, and then you want to maybe try to use LiDAR data, like depth to the object and objects around the camera or radar are important. It might be beneficial to use synthetic data made from a 3D engine, for example, to have these later data points. The animation that you're seeing, that's like just a visualization of that. What you get from that is basically like data points that you can then process.
And here again, we come back to the place that when you start out and want to have more data, start from looking out what kind of data is publicly available, then start look at augmentation and then look at simulation. It might be too expensive if you just jump headfirst into creating sort of synthetic data from the beginning. So,
and this like shows what I think, at least myself, what's the difference between augmented data and synthetic data. Synthetic data is basically that you have a nothing, you have like a zero state, and then you put on digital stuff on top of that, so it doesn't contain anything from the real world. It represents the real world, but it's not that. So for example, here we have fully 3D world. It has no connection to the real world, but it still works for training data. Of course, you should try to mimic the real world as close as possible. Another advantage of synthetic data is data anonymization. This is mostly used on the like tabular data and like numeric data. For example, like fraud detection or like risk calculation or estimation in insurance and financial stuff. Yeah. Mostly always used when there's personal data involved. Because, for example, if you have some consultancy that might help you with your data science efforts, then you just cannot hand them over the personal data of your clients or customers. And then you can anonymize and then you can give them the data to work on.
Except, I mean, of course, there's this example of NVIDIA did this nice example where they synthetically generated faces of not real people at all. I mean, you could use that today. You wouldn't have to create the synthetic data yourselves. It's readily available. You can just use that data set in order to train on top of recognizing people's faces. I mean, there's this ready-made synthetic data sets that you could use quite easily. So just a reminder of the same thing.
Yep. See? So one other situation that we have seen is when you have dangerous or just hard to record events, synthetic data, and like as we can see here, we have some GTA 5 footage about like some pedestrian running to the streets. It's hard to replicate this kind of without simulation. So these are the cases where you should maybe consider using synthetic data to catch these outliers.
Finding those edge cases that are hard to find otherwise. So.
Yep. Let's see. Okay, now we covered how to create the synthetic data, like why should we use synthetic data, and now we'll go to the how side of it. Like, because it's like each use case is slightly different. We cannot just say that use this library or use this tool. We'll just give like high-level tips and tricks that we have seen that work, and then we'll list some tools and libraries that will work depending on your case. Just send us questions explaining your use case in more detail if you want us to comment on specifics.
Yeah, we have some GitHub projects that we are going to link after this here as well, so you can have a look at some examples.
Yeah. So one approach that you can take is that you could focus only on the outliers. So you have most of your data is still the real type of data, but then you have some of those edge cases where you want to have more samples but not be exactly the same.
Yeah, and this might be for the case that maybe your model becomes too biased because you don't have data on specific, let's say, age groups or something like that. Then you can generate that kind of synthetic data.
Other option would be that you reduce the amount of data on all of the other data segments, so you have balance. But like with deep learning, the more data you have basically means the better model you have.
Yeah.
At least if you are working with large networks and neural models. 80-20 split. This is like I'd say the high or maximum amount of synthetic data that I would use, but it's more like a guideline.
Yeah.
That like, depending on the use case, you can have almost 100%, but I would still try to keep some real data in there.
Yeah. Depending, if you're trying to write a predictive model for a fully virtual environment, then I mean you can't. There's nothing to do with reality, so it depends a lot.
It depends a lot. It depends a lot. Let's see. Evaluation. Just to get it out there, basically, the final evaluation of the model, you should use some real-world data to get the actual results. So you shouldn't use the synthetic data for the final evaluation. Of course, when you are training, you use the synthetic data naturally to cross-validate and such, but just to mention it. Most people will figure this out on their own, but it's good to remind people.
It's a good rule of thumb, at least, to have these percentage rules of time, and then just remember to check with real data.
Righto. We have some question. Let's see. How can we generate single-dimensional data? Time series sensor with like data, I mean, thanks. Sensor data, if you are thinking, well, we have that slide coming soonish, but shortly, you basically have the normal exploration tools you have. You are using R or NumPy, Pandas, something to explore and analyze the data. You basically use those same tools. You just need to, depending on what's your like monitoring window, are you like looking 5 minutes, 10 minutes, you need to get the standard deviation or distribution of your data points and somehow categorize what are different events and try to, from that point of view, try to generate similar events.
Yeah, there's probably libraries available for that as well, but you could, if you're starting to do it yourself, I mean, looking at averages or mean values and standard deviations and creating data based on that for time points.
So, well, it was the next slide. So, it's very custom, case by case. If you are working with financial data, it's very different than working with like energy balancing or like just like bank transactions, depending on and what kind of like time range are you following? Are like events more like usually, at least in time series data, events are not just one data point, but it's let's say that it's a fraud, and then you need to follow some number of events or samples depending on what's your like inspection range.
Yeah, we have a question. We have a point first here about where does the ratio 4:1 come for synthetic versus real ones, and I guess we already mentioned quickly that it's depends on the use case really. That I mean, there are cases where you don't want to put too much synthetic data. If you're only trying to come up with some outlier numbers, then you wouldn't want to have that much. If you just don't have enough data and you see that your model still performs well with the synthetic data, then you use more data. So it depends a lot from case to case.
For the ratio, I would say it's more like there's no like academic papers about it that I know of, but it's just what I found that works.
Yeah.
Like you can get by with less, of course.
Yeah.
But it like after that, at least I see in one of like old projects that it like past that it starts to converge badly, like in my opinion, then it won't validate as well on the final evaluation phase. Of course, this is also largely dependent on what is the quality of your generation.
Exactly. So if I write a small code snippet that generates patient data, then let's say that I have 10 for loops within each other or something like that, quite soon it will be biased because it's not very complicated, my algorithms for generating that. So then the model will become biased towards the synthetic data, which is not something you want.
Yeah. So I would say it's more like a guideline. Just start with that, go higher or lower, depending if it still converges well. You can go even like 99%.
Yeah. Yeah.
I have medical use case containing medical data which contains whole patient journey.
Data is numerical and categorical. How do I generate that? It depends on what's your predictive model. What are you trying to predict? I mean.
Yeah, but like we have categorical. The data is categorical, so we have a natural segmentation of the data already.
Yeah.
You need to inspect the whatever numerical data you have, like that standard deviations and distributions of the data, and use that to generate the data points, basically. So it's not, that's the basic principle at least.
Yeah. Yes, should we go forward so we get to the actual demo?
Yes, so we don't run out of time.
Yes.
A lot of tools for 3D. So we mentioned that you on the numerical side, tabular and time series data use the same tools basically that you use to explore the data. But on the 3D side, we have, for example, Unity, Unreal Engine, other game engines. Those are also great for reinforcement learning, but they allow you to model these like real life situations that you can then record using images or radar data or whatever.
Yeah. Then there's also CAD software for more specialized use cases, maybe some processes or power plants or something like that.
Yeah.
And as we talked previously here already, that you really have to have a use case for visualizing it. I mean, if you're just using CAD software to visualize a chemical process, there's probably better ways to do chemical processes than visualizing them.
Yeah, and my tip for the choosing of the 3D engine, if you want to do some high fidelity, like good quality photorealistic stuff, I would go with Unreal Engine. But if you want something easier maybe, then with Unity. I mostly use Unity because I don't need the highest of highest fidelity usually.
Yeah.
It's just, you can make it in Unity, but it just takes more time.
Yeah.
Blender is also, if you are more into like Python programming and like simple animations of objects is fine. And if you are really into like self-driving cars and autonomous vehicles in general, I would suggest trying out the Grand Theft Auto 5. It has really good support for like generating the interesting driving data because it has modeled like how people drive and like how pedestrians walk on the streets and traffic lights and all that jazz.
So science can be fun. You get to play with it.
But if you work with that, it's still mostly programming.
Yeah.
But you just can visualize it with the game.
Yeah.
So that's good. So another con. So for the 3D generation of data, it can be quite resource heavy.
Yeah.
So like you need to use GPUs, maybe multiple ones, and most people's laptops don't have that.
Yeah, but the same is true for training models as well. So
yeah, that's true. So people should have some kind of infrastructure to handle that.
I mean, the same goes with all of these cases. I guess the biggest sort of con is learning curve, or sort of how well do you know how to use these game engines, for instance, how hard is it to get into them. So the cost of building the synthetic data versus the benefit that you get from synthetic data. Mm-hmm. So don't just go and generate synthetic data for the sake of creating synthetic data.
Yeah.
It's going to cost you something for sure to do that. So.
Yeah, and with the game engines, you also need somebody to make the models, make the textures for the models.
Exactly.
You need to know a little bit about shaders, like how lighting works in games, and such. So it's a whole different world. Let's see. So next would be a time for live demo. But do we have any questions?
Yeah, one new question. If the real data does not include the whole design space, can we generate synthetic data for those missing parts of the design space? How?
So the real data doesn't have the full design space. Is that like the problem space? So if you have so you know that you don't have samples of each category. Could you generate samples for that category? Like this is how I read it. Yes, if you know the details about that side of design space or event type or category, how do you want to say it? Yes, definitely, but then you need to know how it's different from the other data points, basically.
Yeah.
It is possible. It is possible.
I'm just going to be silent. Design space is a new concept for me, so I don't even know what design space means in this.
Yeah, might be that I'm also reading it wrong. So I have a hunch what this means.
But good is if you're there, or I know you're there, you can please add to your question. We'll answer it soon. But let's go to the live demo first here.
Yes. So this is a really simple one, but as I mentioned, it's like the principles are same. So here we have a 3D world. We don't have much here working, but there could be like traffic lights and other cars and whatnot. But for this webinar, like I didn't feel like simulating a whole new universe. So I'll just keep it simple. We have a car that is basically just when my Unity starts to work, it's basically rotating. So that's what it does. It's just rotating around and it's taking screenshots of different angles. It could be driving around, it could be fixed location on top of the vehicle, or
it could be simulated in different weather conditions or lighting conditions or whatever you want to.
So I could just like tune the lights how I want. Let's say like I wanted some more brightness in there or something like that.
So right now you're playing with it on your own machine.
Yeah.
Local machine. Yes.
Yeah. But we want to get it like out there in the cloud most likely, because as you could see, most likely on the stream it's lagging quite a bit because my laptop is not that powerful.
So we want to synthetic data generation. You want to add it as a part of your machine learning pipeline. So maybe you have like different pipeline steps where first you extract some data from real data sources. Then you maybe label them or you split them into test sets and training sets. And then you want to augment that either with augmented data or in this case, fully synthetic data. So you want to have these different steps. After that, you want to maybe do hyperparameter sweeps, select the best model based on some metric like accuracy for the model, and then deploy that. So there's very many steps, and this synthetic data generation is just one step in this.
Yeah. So here is like this is also included in the slides. This is open source, the Unity example, how to generate basic rotating car images. It's really simple, but it's in the slides, so you can check it out later. And then we have this Unity example for Valohai. So we are basically guys who are providing machine learning platform that, for example, can generate images for you. Let's see how that goes.
So what we're going to do here now, just a 1 minute introduction to Valohai. So it's built on top of Docker, or your abstraction layer is Docker here. So we're launching a Docker container and we're launching our code inside of it. So we have different steps. Ruksi is going to run the synthetic data generation step, running Unity on one Docker container.
Yeah, so I'll do this quite fast, so maybe you can follow, but I'll try to explain. So I'm just linking the GitHub repository to this project on Valohai, basically. There we go.
And we're ready to go.
Precisely. So we have some like instructions. So how to run the binary. Basically, I built it before this event and upload it, so I can use it. So I don't need to waste your time basically to build it. Let's see. I just need to get something from my desktop because there's some environmental variables that I placed. The file is not that.
Secret stuff.
Very secret stuff. Let's see, like this. I need to dig a little bit deeper. Because it's how I build it basically is that there's a couple of environmental variables that I made it like actually start recording stuff so I can easily test it locally. Here we set up some environmental variables. You can set up these how you want, but this is how I use them. Environmental variables.
So what's going to happen here soon is Ruksi is clicking the execution button. Yeah, go ahead. It starts the AWS instance that he had selected at the top, puts in the Docker container and runs these commands. Also inputting the environmental variables when he starts the Docker container.
Yeah, so now I can, like it starts generating the images. While it's running, I also can start another one. So we have more images coming. Oh, I didn't save the imgen. Oh no, I forgot one environmental variable. But that's not an issue. Because we are playing with the cloud. We can start just more servers.
Yes.
There we go. The third one will work properly. Most likely the first two ones crashed.
So what happens here is we have 3 executions running in 3 different AWS instances, launching up the AWS instance automatically, setting in the Docker containers, running our code and shutting down the AWS instance once it's ready. Yeah, this is all the machine orchestration Valohai does for you.
Yeah, so most likely this won't work or is really slow that it cannot find display. So this most likely won't work. Let's just stop that. Because I forgot to start the virtual display. Same with the number 2, but that doesn't bother us. And the third one should be fine because I remember to start the display. Let's see how it goes.
Yes. And the typical workflow in Valohai here would be if you're running on large data sets or large synthetic data generation sets, you wouldn't even be watching this live. You would just leave it running and come back to it when it's ready.
Yeah, well, it's looking nice. So we can see that it uploaded some files. It's like a tar archive of files. Let's see if I can open it. Opening. I wonder, can I open it? Imgen. There we go. So here we can see that, okay, we have some files that it generated. Like it's basically the same car rotating around. It could be like driving around or anything. Excellent. We can even start it once again just to get more images.
You could also have automatic labeling here in the same.
Oh yeah, yeah.
So bounding boxes around it or whatever you have.
Yeah, of course you wouldn't have those in the images. So
no, you have separate files for
separate files for those.
Yeah.
And then I'll train some machine learning model with that. So it was execution number 3. Yeah. So there we have the chip.
Yes. So now we give this synthetic data as input for the actual training script. So again, think of the pipeline, different steps, have them separate.
Yeah, so you could automate all of this by using Valohai API, but in this example, we are basically just clicking them through because it's more visual. Let's see, watching me type around, it's not that interesting to see me zoom around in this interface.
Yeah.
And now we can see that it tried to train something. Most likely it's gonna do poorly. Yeah, it's not really good. Like
quite few pictures we had there.
Yeah, but all in all, it's just a mock-up example. It's not really training anything anyways. It's just printing out some random numbers. And we could have like some weights and biases to go with that.
Yeah.
Excellent. I think we had the other thing ready already. So yes, this number 4 is ready also. So you could, this way you could generate like hundreds of images or thousands, because it's in the cloud, it's not on your laptop, and just provide like more data sets to the same training. Let's say, oh, it is 4. I can type. There you go. But we are not gonna follow this to finish, but just to show it that you could use multiple data sets after the generation. Okay, awesome.
Yes.
That is what Valohai is.
I think you got the main picture. Should we go to slides?
Yes, we are in the slides. Excellent. Just
all right.
Like basically, machine learning platform. What you saw is one part of Valohai. So Valohai is a machine learning management or deep learning management platform that manages the whole life cycle of machine learning models. Basically, you can do any kind of file pre-processing or generation, training, evaluation, and deployment.
And there's basically 4 things, if you go forward. 4 things that we provide. One is automatic reproducibility. You can reproduce your models, because as Ruksi, you showed there very quickly, but Valohai keeps track of every experiment that you've done, both synthetic data generation as well as any machine learning pipeline steps and trainings and hyperparameter sweeps. You can do automatically click on copy. You can redo them again with the same hyperparameters, the same input data, the same Docker container, the same code, the same environment variables, everything the same. So you have automatic reproducibility.
Even if it's like a couple years old.
Yeah.
Like,
let's say you have a model that's built 2 years ago. You can see that, this was built with this data, with this code, by this guy at this time, this is how long it took. Everything is record kept.
Yeah, and you can see what everybody else is also running, which is nice.
Yeah. Also, I mean, because of that, we also have regulatory compliance. GDPR as a good example. So GDPR states that you should be able to explain how the model made the decision. We do not provide you with the answer, how does your model make the decision, but with the help of Valohai, you can see how did I train my model, and then you can answer that question.
Then we have like, because there's common ways of working, you have a workflow. So let's say what you saw, you have the same interfaces, the same approaches that you basically execute this blob of code or these commands in the cloud. Everybody knows where should they be looking for if they want to learn how a project is managed or built. There's some pre-processing steps, some training steps. It's all in a single YAML file in the project repository.
Yeah, and the data scientist, he only has to concentrate on 2 things. This is my code, this is my data. I don't have to think about what is Docker, how do I launch Docker containers, how do I set up an AWS cluster, how do I set up a Kubernetes cluster to deploy my stuff. You just click a button and say, here is my code, here is my data, and Valohai takes care of the rest.
Yeah. And then we have like, because as we saw, I was clicking around new executions all the time. Like, it's really to experiment with things. You don't have just one GPU or couple. You have like seemingly infinite amount of GPUs you can use. Just start the runs.
It was actually a good demo. If this was your first touch to Valohai, what Ruksi showed you there, very quickly going around, he's very effective there because he has infinite amount of GPUs in the cloud. Can launch servers, 10 at the same time, 50 at the same time, shut them down and do everything.
And if there is a situation that for some reason the server type is not available, what we do is basically just queue your stuff. Yeah. So it will be run later.
Even on-premise stuff, let's say that you only have 10 GPUs, but 12 data scientists, everyone wants to run at the same time, we take care of queuing there.
Yeah. So key takeaways. This is just a recap, basically what we have been talking about. First half was mostly about the synthetic data. Then we went a little bit how to do synthetic data for Valohai. And then we have these like recaps. Synthetic data, like it's self-generated information. you have the control of what you are generating. That's the key principle, in my opinion, that you can generate anything you want.
Yes.
Then when you generate you have the setup, you can generate all of these like videos, time series data, audio, video. It's a more like success with this approach. It's more dependent on the use case. For example, images, I found it works really well, but time series might be harder. You need to somehow categorize different events on that time series.
And on the audio side, really the best use cases are data augmentation, where you augment people's speech with some background noise or something like that to create different audio environments.
Yeah. So yeah, it's like augmentation.
Yeah, it's augmentation, definitely.
The initial setup can be very laborious, especially if you haven't used 3D engines, if you're working with images. On the numeric side, it's not as much, but then you need to understand like somehow how your data events are segmented. So I would, at least with the numeric data, I would suggest looking at the open datasets that we mentioned previously first, because there's a lot of datasets available. But more often than not, at least in the like real life machine learning cases, you have such a custom dataset or such a custom use case that you need to generate the data yourself, unfortunately. Valohai is a machine learning platform that helps you generate synthetic data on the cloud, but you need to write the logic.
And a lot of more stuff as well that Valohai helps.
But the key takeaway from the demo,
yes,
we can do training and deployment and all that jazz also. So that's a thank you, but if you want to stay around, we have also some questions.
Yeah, let's go through the questions, like 5 minutes or 10 minutes or something like that still. Yeah. From the YouTube chat, as well as some of the before mentioned emailed in questions also. But hey guys, there's our email address, website, my phone number if you want to have a private demo of Valohai or more about synthetic data generation.
Or just send questions.
Or any questions.
Just keep it coming.
Yes. You can also add them to the YouTube stream after all. But yes, let's jump to questions. The first one is from Chen. He asks that, what is a feasible and effective way to generate synthetic data for NLP tasks? And I guess sort of the one that's been in the media lately a lot is GPT-2. So
GPT-2,
by OpenAI. So if you haven't seen that yet, just Google for GPT-2 or OpenAI. Generating really human-like texts.
So, But it's hard. It's hard.
Yeah. Or then there's public data sets that it's not synthetic. It's not synthetic data, but again, why not use, if something is available, why not use that instead of generating?
With NLP stuff, I would definitely try to use the open datasets.
Yeah. We also had a pretty similar question in regards to could we write a chat bot in Romanian? So yes, again, but I don't think GPT-2 supports, for instance, Romanian as a language yet. So you might want to see some public data sets with the Romanian language and for your use case, for your chatbot, for instance. All right, the next question was by Satya. How do you know if actually synthetic data is needed and or can help for the problem we are solving?
In my opinion, synthetic data is always useful, like in all cases, except if you have like abundance of data. If you have so much data that like you have gigabytes of coming every day, then you only have benefit if you want to synthesize like outliers, for example.
So synthetic data really is a way to democratize machine learning also, because we can, as smaller companies, we can compete against the Googles and Facebooks that already have terabytes of new data every day. And we as a smaller company, we might not have that much data, so we can synthetically generate that data at least. Yeah,
but like you basically cannot know, because like it's a trial and error.
It's a trial and error, yes. So try it out and see if your model becomes better.
Yeah. Also the problem is that sometimes it's really tedious to start generating it. So maybe buying some initial synthetic data somewhere, trying if it works. I don't know.
Yes, question from Liam was, do you have experience from GANs, GANs, to refine synthetic data to make it more realistic prior to training? I don't think we have.
No, I don't have that much experience in that.
But it's a valid alternative, for sure. I mean, just for everybody else, GANs is generative adversarial networks. Two networks competing against each other, one trying to catch the fake data, and the other one trying to generate fake data, or not fake, but synthetic data.
Yeah.
So you could for sure.
Yeah, you can use it for the like initial training, but yeah, synthetic data, I mean.
Yeah. All right.
Next question.
Next one is, what is the best way to assess the quality of synthetic data sets? We already had kind of the same question.
Yeah, but it's like it's just trial and error. It's really hard to say. You can always like, if you have, for example, images, you can look a couple of them, see if it's any good. It's hard. It's hard. I would just train and try it out.
Yeah. Okay, then we have Jivan asking, how do I deal with classification problem with extremely imbalanced data with 99.99% of positive example and 0.01% of negative examples?
Mm-hmm. So that's just generating more data points on the negative side.
Yeah.
So that's basically what synthetic data is all about.
Yeah. Yeah, if you have really skewed data sets, then synthetic data is really good for making it a little bit less skewed.
Yeah, if you can at least like find the rules that make the negative examples.
Yeah, yeah. All right, we have some YouTube discussions going on. Seems like you guys are answering each other's questions here as well already.
That's excellent.
So we are not needed anymore that much. Better that way. Thank you, community, for helping each other.
Yes, because also we cannot follow the chat all the time, so
yeah,
that's good. That's good.
Yes, I think that was all the questions we had.
Yes, and it's almost like 5 minutes to
1 hour.
1 hour, so that's a good time to stop, I think.
Yes. All right. Hey, thank you, guys. Yeah, email us questions or leave comments in the YouTube stream. Remember to subscribe.
Hit that bell icon.
Yes.
Yeah. Okay.
Thank you. Bye bye.
Thank you. Bye bye.